The syntax of hardware description language is like the grammar of the English language. Describing a circuit in Verilog requires you to write code in a certain format, adhering to the syntax of the language standards. In Verilog, designs are written in small modules, and then multiple modules can be combined to design a complex circuit. Modules have a special reuse ability, where a single module can be instantiated multiple times in other modules. However, unlike classes in object-oriented programming, modules are not dynamic objects at simulation runtime. A module's code is a static template code at simulation runtime. However, there are few ways in which some modifications can be done to the structure of the module at elaboration time, before simulation. Each module can have a set of input and output ports defined as arguments. The module keyword is used to declare a module, and it will have an associated end module keyword that marks the end of that module's source code. Inside the module, one can write continuous or procedural blocks of code that defines the functionality of the circuit. Each statement of Verilog code should be terminated with a semicolon. White spaces and tabs are ignored by the Verilog compiler. Note that all the code that you see in this video is available for you, free of cost, to explore and play around. You will find the links to the code in the video description area. Comments are an important part of developing large code bases, as it increases the readability of code. In Verilog, there are two types of comments: single-line comment and the multi-line comment. Comments are ignored by the compiler and are present only for the code reader to understand what the specific part of code is intended to do. Operators are used to create expressions for functionality declaration. In Verilog, operators are basically of three types depending upon the number of operands it has. Unary operator has only one operand. Example, x equals sign not of AA. Binary operator has two operands. Example, x equals sign A plus B. Ternary operator has three operands. One of the most used is the if-else ternary operator. Example, x equals sign A question mark B colon C. There are also other types of Verilog operators that help with easier description of complex circuit operations, namely arithmetic, relational, logical, bitwise, reduction, shift, concatenation, replication, conditional, etc. For ease of design, we might use number systems of different bases for representation of calculations in a digital circuit. As Verilog code represents a hardware, it supports different types of number system bases as well. There is also a provision to provide the number of bits of data a number literal represents. This is the syntax to write a number literal in Verilog. Number of bits, tick, base, numerical value. Let's look at an example of different base system representations of the decimal number 179. A equals 8 tick B10110011. This is an 8-bit binary number. B equals 8 tick 0263. This is an 8-bit octal number. CA equals 8 tick D179. This is an 8-bit decimal number. D equals 8 tick HB3. This is an 8-bit hexadecimal number. There can also be a representation of numbers without the size or the base format specification. These are called unsized numbers, and they will have a default number of bits, depending on the type of simulator and machine. Verilog supports both the signed and unsigned type of numbers. Any number that does not have a negative sign prefix is positive, or, indirectly, unsigned. Negative numbers can be specified by putting a minus sign before the size of a number representation. Note that Verilog internally represents negative numbers in 2's complement format. Any literal value between the double quotes is treated as a string literal by Verilog. Strings can be thought of as an array of characters. Verilog uses the ASCII system to store the characters. Hence, each character requires 8-bit or 1 byte of data width. It is to be noted that string literals cannot be written in multiple lines. An identifier is the text used as a variable name. This text is used to identify a particular variable, module, or a block of code. These rules are to be followed for declaring any type of variable using an identifier. Keywords are special literals or special text which has certain meaning to Verilog language. These keywords are reserved and should not be used as identifiers. Verilog HDL is a case-sensitive language. It is to be noted that all keywords are in lowercase. This was a basic overview of this topic. Join me at the IISEED's Advanced Designer course, where I explore more deeper aspects of this topic. Here is a sneak peek of what you learn at the Advanced Designer course. There is truly a differentiating, industry-led approach that not only helps you to become a master of RTL design, but also prepares you to face interviews and get job-ready at premium semiconductor and design firms. Explore the entrance exams and check your eligibility for this course at www.iseed.com. Thank you, and I will see you in the next one.